folks, welcome back. Let's take a look now at factoring a polynomial with 4 terms. And polynomial, we could apply it to a binomial and a trinomial, but we typically refer or use this vocab term when there's more than 3 terms in an expression, so 4 or more. And factoring by grouping is pretty common with 4 terms. So I'm going to show you how we factor. You can see this if I kind of scooch to example 2a, right? 1, 2, 3, 4 terms. How could we do that? Factoring by grouping is a common technique for that. So the first thing we're going to do is we're going to group the terms, okay? And we'll collect these terms into 2 different groups so that each group has a common factor, a GCF that we'll take out. And then we will factor out the GCF from each group, and I'll show you that. All right, and then once we factor out the GCF, we're going to refactor, right? We're going to factor out that common binomial factor from step 2. I'm going to show you that. And then if step 2 didn't result in a GCF, or I should say a common binomial factor, we'll try a different grouping. So I'm going to do example 2a in 2 different ways that work, and then in 1 way that doesn't work, because I want you to kind of see that there's a couple ways to do steps 1 through 3 in this particular problem, not necessarily every problem. And then I want you to see what does it look like when it doesn't work, because that's also important to kind of see. All right, so I'm going to scooch this up, and the first thing we're going to do is we're going to collect our 4 terms, right? Polynomial, 1, 2, 3, 4, many terms, polynomial. We're going to group these into 2 groups. And the typical way I start this is I look at the first 2 terms as a group and the second 2 terms as a group, and we'll see if that works. And again, some of the time it works, some of the time it doesn't. I'm going to show you 2 options where it works, 1 where it doesn't. So let's just say I opted to group these 2 together. So I'm going to make it binomial and then another binomial. And from each of those binomials, I'm going to factor out the GCF. So that would be step 2. So I've grouped these, first 2, second 2. And now I'm going to factor out the GCF from each binomial that's left over. So if I look at this term, PQ and 5Q, what do they have common to them? A Q. All right, so I'm going to factor out this Q. And from factoring out that GCF, I'm left with P plus 5. All right, so I'm going to put that binomial in parentheses, right? Now I'm going to look at my second binomial of 2P plus 10. And what's common to those 2 terms? What's the GCF in this binomial now? It's a 2. So when I take out the 2, I'm going to be left with P plus 5. And like always, you can check this by remultiplying, right? QP is PQ. Q times 5, 5Q. 2 times P, 2P. 2 times 5, 10. All right, but now I've taken these 4 terms and collapse them or factor them into 2 terms. Believe it or not, this second expression here, this is a binomial. Here is the first term, right? And here is the second term. And what do they now have common to them? They have this binomial factor common to them. So that's what step 3 is saying. Factor a common binomial factor from the results in step 2. All right, so step 1, I grouped them. Step 2, I factored out the GCF. Now there's a new GCF, P plus 5 is common to both of these terms. So I'm going to factor out the P plus 5. If I factor out a P plus 5 from this first term, there's a Q left over. If I factor out a P plus 5 from the second term, there is a 2 left over. And now I have I've completely factored this polynomial because P plus 5 is prime, Q plus 2 is prime. In general, when you get down to linear factors, you're looking at prime terms. And when I say linear, because this is P to the 1, this is Q to the 1. Anytime you have a variable raised to the first power, that's a linear factor. All right, so let's just keep in mind, right, I had P plus 5, Q plus 2. All right, so I want to show you a second way I could have done this. So let's say instead of grouping the first 2 and the last 2, let's say I group the first and third, and I group the second and fourth. I just want you to see an alternate way, right? So let's say I went PQ plus 2P, I rewrote this, and then I had 5Q plus 10. All right, I just want you to see an alternate version, okay? So now if I group these 2 together, now if I look between these first 2 terms, right, this new binomial, what is common? There's a P common, so I'm going to factor that out, right? So I can factor out the P, I'm going to get left with Q plus 2. All right, Second binomial is 5q plus 10. What's the GCF there? A 5, right? And what am I left with when I factor out that 5? Q plus 2. And now you can see I have this common binomial factor here, right? This is one term. I know it looks a little uglier. This is the second term, looks a little uglier, right? 4 terms here, 2 terms here, right? And it, kind of a way to see it is there's 3 different plus signs here. There's only 1 different plus sign here. So there were 4 terms separated by 3 plus signs. Now there's just 2 terms separated by 1 plus sign. And admittedly, these terms are a little bit more convoluted, but it's still 2 terms. First term, second term, and what do they have common to them? What is their GCF? Q plus 2. And when I factor that out, I'm left with P plus 5, which is the same end game answer I got, just in a different order. And since multiplication is commutative, right, it doesn't matter if you do P plus 5, Q plus 2, or Q plus 2, P plus 5. That's the same expression, just in the same sense that 3 times 4 is the same number as 4 times 3. We say multiplication is commutative. All right, so I want to show you what this looks like though when things maybe don't work. All right, so if I go back and I'm going to put a little separation here, let's say, and I'm going to erase all of this because I have so many squiggle marks here. I've tried the first 2 terms, the last 2 terms. I've tried first and third, right? Let me try to group first and fourth and then second and third, right? So if I try and do that, if I do PQ plus 10 as a grouping and then 5Q plus 2P as a grouping, right? If I try and take a look at these have no common factor, right? PQ plus 10 has nothing in common. 5Q plus 2P has nothing in common. So in a sense, these are the only binomials that survive, and those are not common to each other, right? So since I tried to group that way and it didn't work, that's just my clue that, hey, this is not the right grouping. So try a different grouping, okay? All right, so let's try part B. I've got 4 terms. All right, and let's see. I'm gonna go ahead and just, for doing this, I'm gonna put the first 2 together and the second 2 together. All right, and I think I haven't tried, well, actually, we will try this a second way. I do wanna make sure I do this a couple ways, but I'm gonna start, I always start with first 2 and last 2 and see what happens. Okay, so if I look at this first binomial now, right, and I see what's common, 2xy and a 3y, there is a y common to them, right? And so that's gonna leave me with 2x plus 3. And there's nothing really in common with 2x and 3, but just for the sake of doing this, I'm gonna quote unquote factor out a 1, and I'm gonna be left with 2x plus 3, because 1 times anything is itself. So I have y times 2x plus 3, and again, if I redistributed, right, y times 2x, 2xy, y times 3, 3y, 1 times 2x, 2x, 1 times 3, 3. But now you can see in these 2 terms, this new 2 terms, right, I have a 2x plus 3 in common, and what is left over when I factor that out? Y plus 1, okay? So there's my endgame answer. Let's say we group this in a slightly different fashion, right? Let's try the first and third and the second and fourth, all right? So if I do it this way, if I do 2xy plus 2x plus 3y plus 3, let's see how this would work, because maybe this one unlocks better for your brain than this one, which is fine. We just need to get to that end game answer. So if I kind of group these, right, what's common to 2xy and 2x? Well, 2x. When I factor that out, I'll be left with y plus 1. What's the GCF between 3y and 3? It's 3, and I'll be left with y plus 1. And look, that back factor, that back binomial matches. That means we're unlocking this correctly. And now in these 2 new terms, right, 4 initially, now 2, I factor out that GCF, that binomial that was common, and I'm left with 2x plus 3. Right, and you can see that this endgame answer is the same as this endgame answer. They're just written in the opposite order, but since multiplication is commutative, again, 3 times 4 is the same as 4 times 3, it doesn't matter which factor you write first. They're both correct expressions. Okay, so let's scooch this up a wee bit and see if we can't solve or at least factor these last 2. So as I look at this, you know me, I'm gonna go ahead, I'm just gonna factor the first, I'm gonna group the first 2 and second 2, see if it works. All right, so what's common to 2a squared and 4a? I think I can factor out a GCF of 2a from there. and I will be left with a minus 2. If I look at 3ab minus 6b, all right, 3 and 6 have a 3 in common. AB and 6b just have the b in common. 3ab to, or what do I need to multiply 3b by to get to 3ab? I need an a and then a minus 2. Oh, okay, and that unlocked, right? I see it unlocked because that back binomial, right? I've got that common binomial factor. So now let me go ahead and factor out the a minus 2, and I'm left with 2a plus 3b, right? And there we go. Okay, so I've factored that one. I have a feeling just looking at this, and I haven't personally tried it, I have a feeling I could group the first two, or the first and third, and the second and fourth. Actually, just for the sake of trying it, let's find out. And do I have enough room on here? Let's see. So if I did this as 2a squared plus 3ab minus 4a minus 6b. And I don't know if this will unlock. All right, I'm going to scooch this up just so we have enough room on here to kind of test it out. So let's see if this unlocks. All right, if I factor, it looks like these first two terms, if I group it this way, the only thing I have in common is an a, so I have 2a left over plus 3b. Okay, I'm going to factor out a minus 2 here. I'm going to take the negative with me, because if I factor out the negative 2, that'll leave me with a positive 2a. Negative 2 out of negative 6b is plus 3. Oops, no, I messed that up. It's plus 3b. All right, oh, and then it unlocks, right? So I have a 2a plus 3b that's common. And just to kind of give you a counter, right? Like, let me show you why I sent the negative with it, all right? So let me go the other way. So look, a lot of folks, and this is totally reasonable, are like, oh, let me factor out a positive 2, and then I'm left with negative 2a minus 3b, right? So if you do that, you can notice this back binomial factor is not the same. But if I take the negative out with this, right? If I changed this, like we saw before, to minus 2 to have that positive lead coefficient, then I'm looking at 2a plus 3b, because negative times positive is negative, negative times positive is negative. And you can see now that back factor, that back binomial matches. So when I factor out 2a plus 3b, I'm left with a minus 2, right? A minus 2, okay? All right, so let's do this one again, or not this one again. I'm gonna group these. I'm gonna just go first 2 and second 2. The GCF with x cubed and 3x squared is x squared. That'll leave me with an x plus 3, right? X squared times x cubed, x squared times 3, 3x squared. I'm gonna take the negative out, all right? And when I do that, negative 5 out of negative 5x leaves me positive x. Negative 5 out of negative 15 leaves me positive 3. And you can see that this back factor matches. So when I factor out the x plus 3, I'm looking at x squared minus 5, right? X squared minus 5. Now this is our first time, at least in example 2, where when we factored something out, we had a non-linear factor, right? This is actually a quadratic factor because there's a squared up here. Every other time, you can see that we had, right, up on a, q to the 1, p to the 1, what was this, y to the 1, x to the 1, a to the 1, b to the 1, a to the 1. All of these were linear factors. And we're about to go into this. Anytime you have a linear factor, right, where the highest degree of your variable is 1, it's prime. And there are plenty of times when you have quadratic factors, right, here, where your factor is not prime. And we're going to get into this in a little bit, but I could write this as a difference of squares. If you've heard of that term, great. And if you hadn't, no problem. We're literally going to get into it in example 3. But just to kind of give you a preview, I can rewrite this as x minus root 5, x plus root 5. All right, because this is x squared, which is a perfect square. And you can write any constant as a perfect square, as long as you're using a radical, right? Just off to the side, right? Square root of 5 squared is 5. So when you have x squared minus root 5 squared, it can factor into x minus root 5, x plus root 5. And maybe you're noticing these are conjugates. And we had talked about previously how when you multiply conjugates, the outer and inner term cancel. All right, but we're going to focus on that a little bit more in example 3, okay? See you soon. Thanks so much. Bye.